Right now, a tiny voice from space is telling your phone exactly where you are. But here's the secret almost nobody knows. If we hadn't listened to a man who died in 1955, that little blue dot would be wrong, and not by a little. It would slide off course by about 10 kilometers every single day. The man, of course, is Albert Einstein, and the strange truth he uncovered is this: time is not the same for everyone. It doesn't tick at one fixed speed across the universe. It bends, it stretches. It runs faster or slower depending on how you move and where you stand. That sounds like science fiction. It's actually how your phone finds you. Let's start with what GPS really is. About 20,000 kilometers above your head, a fleet of satellites is circling the Earth. Each one carries something extraordinary, an atomic clock, so precise it would lose less than a second in millions of years. These clocks are the whole trick. Without perfect timekeeping, GPS simply cannot work. Here's why. A GPS satellite is basically shouting one message over and over: I am here and the time is exactly now. Your phone listens, then measures how long that message took to arrive, traveling at the speed of light. From the delay, it works out the distance. Catch signals from several satellites at once, and it can pinpoint you on the planet. But notice how delicate this is. Light travels about 30 centimeters in a single nanosecond, a billionth of a second. So if a satellite's clock is off by even a millionth of a second, the distance it reports is off by 300 meters. Timing errors don't stay small. They explode into position errors. And this is exactly where Einstein walks in. Back in 1905, Einstein published Special Relativity. One of its wildest predictions: the faster something moves, the slower its clock ticks, as seen by someone standing still. Move fast enough and time genuinely slows down for you. This isn't a measuring mistake. It's not the clock breaking. Time itself runs slow. We call it time dilation. Now, GPS satellites are not slow. Each one races around the Earth at roughly 14,000 kilometers per hour, thousands of meters every second. At that speed, special relativity says their clocks should tick a little slower than ours down here on the ground. Slower. Hold on to that, because the story is about to flip. Because Einstein wasn't finished. 10 years later, in 1915, he gave us general relativity and an even stranger idea. Gravity also bends time. The stronger the gravity, the slower time flows. Deep in a gravity well near a massive body, your clock crawls. Climb away from that mass where gravity is weaker and time speeds up. Think about where those satellites are. 20,000 kilometers up, far from the bulk of the Earth, gravity is much weaker than at the surface. So general relativity says their clocks should tick faster than ours. We're stuck down here at the bottom of Earth's gravity well, and our time runs a touch slower than theirs. So now we have a tug of war. Special relativity, from their speed, tries to slow the satellite clocks down. General relativity, from the weaker gravity up high, tries to speed them up. Two of Einstein's greatest ideas pulling in opposite directions on the very same clock at the very same time. So which wins? Up at GPS altitude, gravity is the stronger effect by far. The speed slows their clocks by about 7 microseconds a day, but weaker gravity speeds them up by around 45. Add them together, and the satellite clocks run fast, gaining roughly 38 microseconds every single day compared to clocks on the ground. 38 microseconds, 38 millionths of a second. It sounds laughably tiny, the kind of number you'd round away without a second thought. But remember our rule. In GPS, time errors become distance errors and they grow fast. So let's actually follow that little number and see where it leads. Multiply that daily drift by the speed of light and the GPS picture falls apart. Your position would wander off by roughly 10 kilometers a day. By lunchtime, you'd be blocks from where the map insists you are. By tomorrow, in the wrong town. Within a week, navigation would be utterly, hopelessly useless. Here's the part I love. The engineers knew. Before these satellites ever launched, they did Einstein's math and deliberately built the correction in. The atomic clocks are tuned so that once they're up there ticking fast, they end up matching our time perfectly. Every GPS satellite is, quite literally, a working monument to relativity. And that's what makes this so beautiful. Relativity isn't some abstract idea trapped in a textbook or a black hole far away. It's running, right now, in the device in your pocket. Every time you find your way to a new restaurant or follow a map in a strange city, you're trusting that Einstein got the nature of time exactly right. He worked it all out with pen, paper, and pure imagination decades before anyone dreamed of a satellite. He never saw GPS. He never held a smartphone. Yet his ideas quietly guide billions of journeys every single day. So the next time that blue dot finds you instantly, give a little nod to Albert Einstein. Time bends. Clocks in space really do tick faster, and a discovery from over a century ago is the silent reason you never get lost. If that gave you a little jolt of wonder, stick around here at the Curious Owl. That's exactly what we're here for. Bite-sized wonder every day.